by the director for Peter Norvig, who goes to some classic research in cybernetics that argues any sufficiently complex domain of human endeavor. Chess, music, operation requires 10 years worth of work to become really good at. As a result, it goes back to Simon back from work at Carnegie Mellon University. And they argues that the same is true for programming. Programming is a discipline I see as valuable and unlike a comment heard 2 weeks last week, rewarding. You get good at a game and you know how to enjoy it. But still, any endeavor that's a confluence of math, form of logic here, engineering, human factors, and sociology is not necessarily going to be easy to get good at. We classic import this that has about 20 different aphorisms to talk about Python. Simplicity is beautiful, seek the one true way, and so forth. If you like to cheat and go to the back of your texts, go to the chapter Dark Lots if you bought the book, and in it you'll see some interesting observations like these. It's one of Python's earliest advocates. He's been teaching the language for 20 years. I've watched Python work over time from simple to a sophisticated tool with a steadily shifting scope. There's a lot, he sees a lot of, and I agree, I see a lot of the same factors, the same complexities that have shown up in languages like C++ and Java. They've crept into Python over the years for a variety of reasons, some of which, again, goes back to this point that reality has to be more complex than people would prefer it. And various constructs are there to deal with various concerns that arise in the domains of Python where Python has been used. So, it's still, Python is relatively simple and it's rapid feedback. The simplicity from what is achieved in part by throwing out safeguards. The Python advocates will argue that class safeguards, like having to declare the types of your names before using them, are not important. And many small applications, maybe they aren't important. When you start writing really big systems, it's how many mistakes I found for my own part. It's amazing how many mistakes I can make. And when I start writing big code, do miss language that check my errors at compile time. Still, Python is a terrific teaching tool because of the point about rapid feedback, because you type stuff in and have Python come right back again. So we'll emphasize the positives, I hope, in this lecture series. Common text. The text is massive. I was one review by Will Lee. I don't know who Will is, but I think he captured the spirit correctly. If you're a seminar because you want to learn Python in 21 days, we'll teach you some things, but lots is not the best for that. There are some other sources on the net that give you a crash course of you can do this, you can do that. The source will also probably gloss over some of the points that will trip you over time. And really nice thing about LUTs is that LUTs is careful in the process of telling you how the language works, to tell you where you can stumble and fall. Okay. So the approach to these slides anyway is as fundamentals. It depends on fundamentals here. Python, like other programming languages, supports a set of core data types. And the types are kind of like the scales. Your mission, you do minor, major, mixolydian, various modes. You're in the scales, and that's the basis for creating music. The same way the basis for creating content in programming languages. So like to emphasize a hands-on approach to get for what these constructs are and what they can do for you. Some summary slides, but most of my slides are going to be try this, look at that, think about the third thing. To get benefit from these slides, you need to be there typing the stuff in. So consistently, this and next week, and if we go into a third week with the slides, hopefully we don't, type into a text editor. When you stop in blue, there'll be some highlighting in gold. Bring up a text editor, type into a text editor, then copy and paste what you type in a Python session. One version, upper, lowercase, and white space matter. White space is really important in Python because whenever you have sections of code, white space initial indentation is used to delimit the sections. And to throw one space too many in or leave one space too few out, Python will write an unexpected indent. Okay. Even with the indentation, Python also looks for a single blank line to end some blocks of code, loops, and function definitions. And if you leave one space on the following loop, Python will say, what's going on? I'm expecting you to continue. Okay? So the way the exercise is to say, here's a slide, type the stuff in. Everybody, I hope, should have Python up and running somewhere on our right now. You don't, you get stuff going. I will say, stuff in, I'll look around the room, for maybe a minute or so or more, depending on the slide, ask people where things stand. Patty.
To do Python 2 or 3.
So,
do you want to do Python 2 or 3?
Python 3, please. I think the examples I'm showing, most of them should work in 2, but I have slides if there's time. I'm here the first week of July. So if there's time, I'll get them. Otherwise, I'll hope one of Steve's colleagues, Chris Link or Dave Williams, will present them. Discuss the differences between 2 and 3. One of the questions that I've had over my time here is, what Python 3? And the hidden message in that question is, I know Python 2, why should I bother to change? And Python 2 is now legacy code. Okay. So I learned Python 3. A bunch of packages have moved to Python 3. Albeit slowly, is moving to Python 3. Red Hat release will Python 2.7. Okay, though that's still supporting Python 2.3, one of their legacy codes. Okay, so I will be running Python through. Again, I'll put a slide with blue. I'll ask people to type the stuff in. At a time, when I see people's hands off the keyboard, I'll see about 3/4 of the class is done. When 3/4 of the class is done, I'll give the rest of the class a little bit of time to finish up. And I'll ask people who get it, as I'm going through, to help people who aren't getting it. And if they're here who's not getting it, I'll ask you to raise your hand, and we'll do a scramble. We'll see if we can help you find what's wrong. One reason for having people type in the text editors is that copy and paste is going to be a lot faster than retyping some of these examples from scratch. Okay. Question times. Are there any questions to this point about what I've said? Okay. Start a Python session, go to a line, type Python, or if you're still with an IDE, to end the session, type exit, open, close Right. Begin scalar value types. Int, integers, float, complex values, booleans, none type, the value and type names properly. Okay. Set of examples, go.
Let's shift binary or otherwise.
Just as if you're combining. So if you're saying less, it's like multiplying by 2. If you're saying less, it's by 3 places, like multiplying by 2 to the third, or 8. Right by 3, it's dividing by 8, truncating division, throwing out any sort of remainder.
So binary. 1, 2, 2. So over 1. One, 2, 0, 0. 1, 2. So you just scoop.
And just guess, Jerry, who are the people to your on either side of you up here? Sorry, Ronnie, and Nick. Ronnie, Nick, Jerry, you guys good up there? John, good. Right, are you good? Sorry, it's gonna take me some time to learn names. Robert, are you good? Next, Robert is Gavin, are you good? And Bobby, are you guys good? Okay.
Better than I am.
Who's next to you, Chris? Pardon? Brooke. Daniel, Joe, and okay, what Python is best calculator. The show you a few tables. So another check. Are people at this point? Is anybody working? Are there any surprises? Nobody surprised. One of the examples. 010 power. With 4.
Infinity.
That was a bit of a surprise. I didn't expect that. Another size from Python 2 to Python 3. The notation for octiliteral change. The Python code should have 010101. That used to be binary or octal in the old Python. I forget which. It's gone. It blows up now. Okay. Here is the first fancy example of a double back and forth. Screen size full.
Sorry, when you first switched software, it said your video display. Well. Sorry.
Your flash. Virus. But that means letters in the first name.
Oh, and updates have this way of the other side. I've seen that happen before. Okay.
Make it. Yep. Unmute. And
Two, we're good.
you're good.
And now the presenter, share the desktop.
And we're in, sort of.
Okay. Apologize. What happened was and Adobe crashed my video driver. So let's where we double Ryan range 10, Virginia range 10, print curly zeros, curly brace, comma, format I times J. This should be a multiplication table, a softly formatted multiplication table for the 0 to 9. Take all elementary school. And it is 2 single quotes. Note the indentation, please.
There's 2. No, there should be 2. Missing.
Okay. People are looking with mildly bored. Did this work? Is there anybody still typing his problems with getting the double for loop to work? Okay, so,
There's still a syntax error.
okay.
I think we're missing a quote somewhere. Maybe.
Computer? Bring up Python. And I can hold this in. This are my slides. And I hope to be seeing something roughly that looks like that. 2 quotes. Okay, combine points. These are comment. Double quote row. Do you 2 single quotes for the end? Okay. Combine points for the example. We can a Python function that generates in response to an iterator, a for request for value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Dot format list of format values. It's the way that formatting is now being done in Python. There are ways of formatting Python in the past. Called the binary %sign operator. It does some old Python code. That's gone. That's now deprecated. Deprecated meaning we're going to kick this out of the language someday completely. Stay away from it. For those who know C, you can also get C-style formatting. But what I'm showing you is what the references are now recommending for readability. Python start with 0. You don't start counting from 1, 2, 3. You start counting 0, 1, 2, 3, 4. Curly bracket 0, close curly bracket, in a format list means get me the first item in set of arguments for format. Here's one item. items J. Final about the example is that a print statement normally ends line by printing a new line. Here, end equals single quote. That chooses the current line without sticking a new line. And then stack 10 bit values on a single line before print in. It closes out my times table. So far. Is this a good point to turn the page? Patty, are you good?
Oh, just keep.
Okay. Well, here's for loop. Okay. Between this for loop and the last for loop is for saying type the things into the text editors. If you do, you'll find that a lot of the examples read pretty much the same from slide to slide, except for one tweak. Go back to your old example and tweak so you had a colon and 4. And you'll get this piece of work. Also get rid of her name pulling up again. I'm sorry, you are Gavin. Good, Gavin. Okay, well, you good on this. John, Gavin, right, John. I'm seeing green shirt. Rock, are you good on this? Yes. Okay. Type 3 on your computer. So, if you want to over next to Gavin while you're installing this, oh, you'll be good. Okay, Jerry, Rob, one was I'm sorry, Robbie, Ronnie, and Nick. Are the Nick, are you good with it? Okay, I know that I've said the slide. I know the world is somewhat confused right now. The two from all seen on the website, the Python developers really do consider it legacy. Okay, so that's one reason that I teach free. Okay, I'm sorry. And I try to remember names again. Daniel, give me 5 passes on it. Next to Daniel is Joe. Joe is Todd or UK Todd. Dan, Joe, Todd, Ronnie, Nikki, Robert, Gavin, Jim, are you good? No, that's fine. This is what you. The problem is, is the final print lined up under the 4J or is it lined up under the print? It's a why that final print lined up under the 4J if you want to get it to run after every time through the loop. Try that again. Yeah. Okay. Are you good? Next to Chris is. Sorry, Ben, are you good, Ben? Okay. Pat, are you good? Sort of. Okay. Well, is Patty good?
I'm the last watching her talk.
Just take a second.
You don't want to know. Oh.
Sometimes it's common, but it's still a lot of fun to watch. It's sort of like a slow moving train wreck.
We'll be here all day.
Yeah, well, sure.
Okay, okay.
I'll call it in.
Double.
Single.
Single quote. Then two spaces, just two spaces in print. Return. Return.
No, we only got 3 more of those to
We are cool. Patty is getting the output. Okay, so
Premium breakfast.
Python online documentation. Most of what I've learned about Python has come from www.python.org. Off of that, there's a docs page. The docs has a library section to it. The library, the line under it says, keep this section under your pillow. And I have repeatedly turned to the library to learn stuff that I'm going to hear today. The library, for example, has extensive discussion of how you get these formatting constructs to work. And the cool ones is this convention, you put a colon and either less than, equal, greater than, followed by a number. That gives you a width, a column width for putting up values. I don't know about you, but one of my classic headaches when I'm coding reports for other people is making sure that everything gets in the right place in the column. So formatting stuff early, because to me it's what I, okay, less than means less justified. And in the example, the what, I just don't want to crash the video driver again, but let's hope that it won't. Edit. A bunch of numbers slammed left in their columns. Agreed? Okay. On the next example. Okay. Same as the, except throw an equal in there, and we'll find it. You have been typing the stuff in the text editor. Copy and paste quickly. If you,
Hello.
hello.
Yeah.
I hear someone saying hello.
Yeah, this is Dwayne.
Dwayne.
Yeah. Hey, I was trying to send a message because I got a syntax error and I still recovered from it.
So
From the example.
you once in pain, and now your pain is in the end. Me, Dwayne.
Wait, sorry, I didn't hear that. What'd you say?
You were once in pain, but now your pain is an end. Is that what you were telling me?
No, I'm still in pain.
He's in pain.
Yeah.
This is sad. What is your pain, Dwayne?
That print. So I'm the second to last line in that Python program, and I'm printing it by hand. So I used to double. Oh, okay. Shoot. Hold on. Let me try something. I think that happened.
Somebody's running a vacuum cleaner in the background.
Really?
Hear you. You just said, "Oh shoot, let me try something." Is that correct?
Yes. So, all right.
How
It's still.
lines up with the 4?
So is that supposed to be a 5 in there? Because I'm doing it where it would print parentheses double bracket 0. So there'd be a colon equals 5 in there.
Okay, I also threw another slide. That's the previous. That's the next slide. Here's the slide before. This is the slide you were on. Is that
Wait,
right?
no. Go one back up because I didn't even
Go
get
back
past.
to the beginning.
Yeah. That one didn't work for me.
That didn't.
Yeah.
Okay.
Yeah, and it says syntax error, invalid syntax, and then it points to the equal sign.
2 single quotes.
Okay, use that.
Quote.
Right. Yeah, it's giving me that. Should I indent? How many spaces do you indent?
whenever I type Python, I use the Ruby convention. What they do in Ruby is every time you go in a block, you go in two spaces. That's pretty well. It's not flooding your code with spaces, but it's not to be visible. So there are two spaces here, four here, two spaces here.
Okay. It's still not working. Just
We're communicating to me from Boeing.
the thing. So what happens is I have to right click on the desktop and left click return to meeting window, and it moves your desk, and I go to where I see everybody's names, and then this is what I'm broadcasting. So
Are you in 5700 at all?
you mean no, 5100?
Okay. Any chance I'm by 5700 because it's very hard to do cyclic debugging.
Okay, I'll be there in a second.
Okay, come by 5700. I'm going to keep going with the exercise. When you get here, we'll look and see exactly what's going on. I need to see what you're mistyping in order to figure this out.
Okay. All right.
Okay.
We'll see.
Okay, so the next example, one other minor formatting convenience. It's a nice convention. If you omit the number, and if Python simply picks up the next argument and lists. So the argument in format lists, no number implicitly refers to the I times J and equals centers the value. Please try this. If you get it. While people, I will try it. Again, a bunch of numbers. So take this to make sure. Okay. Papa, I remember. Right? So are you guys are again begin Ben and sorry, thank you. You practice saying your names. Good. Second row, Ben and Fritz. Jacob, good. Gavin, good. Ryan, John, Robert, Nikki, Jerry, Bobby.
Watching the train wreck, so I'm good.
Patty, typing things into a text editor and copying and pasting from the text editor.
Fun way.
Okay, no, when I said please type up into a text editor and copy and paste the speed thing.
Oh, yeah. Well, yeah, she got it.
Okay, so what I'll do now is throw the last example into a thing, show you right justification, and have you run the function a couple times. In Python, are defined with executable statements using the keyword def, DEF, short for define. So, and now going in 3 levels, because outermost level is the def statement. Okay. Now, well, for those of you with some programming experience in the audience, I do appreciate people bearing with this first part when I'm trying to do the pace. We'll pick up some. There'll be some more concepts, some more curves to take people who are in the audience. I think we have some who have little or no programming background, and make sure everybody comes up to speed at a reasonable pace. And it looks, again, quarter rule, about 3/4 of the audience seems to be good. See if I have names now. Keith, no, Nick, Jerry, Ronnie, good. Robert, Square, good. Good. John, good. Jacob, good. Ben, fine. Chris, good. Daniel, Joe, and Todd. You guys good? Good?
I'm good.
Perfect. Okay. Okay. The next thing we're going to do is analyze a bit further what you just saw, and tweak it so that we can generate tables for generators, not just location, but lists, division, addition, subtraction. And so you're going to parameterize the operator. Hard coding the operator, what we will do is pass the operator in as another parameter to our function. And if you pass an operator, if you pass a function, use that just as a function. Now, you can't put the symbol times or the symbol multiply or the symbol divide into a function called directly. What we do is go and predefine Python functions that give the effect of plus, multiply, divide. Those predefinitions are in a module called operator. Action in Python is to import stuff from the Python library into your program. And because the way that you make a module and available to you, say import module name. So to go back to the last example, add import operator to define in the example. Second parameter called op for operator, change J to op, comma J, and then these operator parameters to your code and see what happens. Am I making sense? Next. So, back around and start. Todd, Joe, Daniel, Chris, Ben, Bobby, Patty, Jacob, Gavin, Ryan, John, Robert, Russ, Jerry, Nick, all good. Wait,
Yep, he's running 500. Yep, he's running 500.
okay, and so this trick of parameterizing functions is a powerful way of generalizing codes, one that I use repeatedly, not just in Python, but in now that languages like C++ support this style of programming. You know. So one of the problems, the last example, the potentiation. If you give me an example of the way I've asked you to do it, and I'll do this, come on, escape, you'll see what the exponentiation example is in this. Stuff running all over the place, right? Because exponentiation gets numbers pretty big, pretty fast, and I haven't really set aside the right room in the columns to hold the numbers that I'm generating. Okay? So another classic headache in programming, if you're generating outputs, and everybody's always generating outputs, is knowing how to leave enough space in your print, your columns, for your numbers. Okay? What I have here is little to the double asterisk example, and here, going back in the slide, where I'm building a format string that has a number that's big enough to hold to leave enough space in the biggest column I need for my table. Okay. So what you will see here in this example, the big number that I'll be generating is 10, say, or 5 to the 5th, or 6 to the 6th in this particular case. So my code is generate formats that will be leave you space in the column to get the numbers in there. On J power. So I'm going to run this example, put it in, make the changes, run it, and once running, then we'll talk through it one more time to pick up subtlety. Go over. Dwayne, do you have 3 running here, or is it crashing on you? Okay, well, this is, if you have any questions, raise your hand, and I'm making myself useful rather than just wearing out my shoes. Should I go over or no? Well, talking about three-dimensional arrays, lay in the sequence of basic examples. The answer is you don't deal in single values, you deal in structures. And on you have a structure called the list. And typically speaking, if you use what's called a dense array, an array that has mostly a bunch of different values, use a list of lists and represent an array. If you have sparse array, sparse arrays are arrays that are like mostly zero except with a couple values here and there. There's another structure called an associative array, or in Python lingo called a dictionary, that basic key value pairs that work really well for sparse arrays. And in my slides, I have a lot of examples of dicts and lists coming up. But those are coming up after I finish dealing with the scalars. It's a fair question. Oh, and I make my slides available at these lectures. These slides are meant to serve as a reference catalog. Okay, you take the stuff away, and I hope that you have some things to go back to and say, here's how I can do some simple things in Python. Let's see, up in the back row. See, I still remember. Nick, are we good back there? Jerry and Ron. Robert, are you good? Gavin, are you good? Dwayne, you on 3 up yet? Okay. Are you good with this? John, okay. Chris, Daniel, Joe, and Todd. Okay, so we introduce. You see how the format piece works. String to me is a really kind of a cool feature. You can do the trick shown you in languages like C, a language where you use a program created string as a guide for content. You've noticed that the format string here generating a field that's 5 spaces wide, because the biggest thing I'll print, 5 to the 5th, is like 60 to 125, which requires 4 characters to print. Does that part make sense to people? Okay, again, how big to make things? I can make things because I can take my biggest number, turn it into a string. Number of places in the string. That's what len does. It tells me how many places there are in the string. Now I can 1 space to separate columns afterwards. Fixed number of places, add to the size I'm getting, and wrap that particular expression in curly brackets like get a format string. We tend to should places to do, and I'm leaving 1 extra space for the place. 10 then followed by 10 zeros, right? And you need extra space for the initial 1. So that counts up to 11. And then you want extra space to make sure the columns don't run together. Does that make sense? Oh, only go to 9 because range goes to but not including. Range is a half open interval. A not uncommon idiom in programming languages. Ranges in C++ works exactly the same when you get what's called a half open interval. You the starting point up to but not including your ending point. So in that last example with power table of 11, you would make. Okay. The other feature of the language this example is introducing is the return statement. If you want to give back a result, use return followed by your result. If you don't need a return. That's clear. Again, if it is not clear, please raise your hand. My motive for being here is to serve you and to serve Nix. And if you're not following, I'm not doing service. Okay, so here is another tweak to the last example. We're greater, but instead of starting at 0, we're starting at 1 to build these tables. And the reason at 1 is, as Dr. Science, the comedian, used to say, if you divide by 0, the universe goes up in smoke. And all reality, as we know it, fails to exist. So try typing in, seeing it does what it should.
Like beginning.
You get better typing all the time.
Yeah.
Yeah. Okay. Is it possible? Just one of the more frustrating aspects of teaching a class like this is that it's very easy to get, actually I shouldn't say teaching, I should say taking. One really frustrating aspect of taking a class like this is you get 95% of the type and write, and you miss detail. You get a message that says syntax there, and no idea in blazes as what is going on. So while I do apologize to people in a couple cases who keep stuff in mind, it's really important. For me, as a faculty member and as a programmer, the most frustrating thing is to hit. So again, some of the important takeaways I hope from this first series of examples at this point is Python 3 is not Python 2. It does matter. You need consistent. You need to be fanatical about things to line up where we're supposed to line up. You need to be precise about leaving blank lines at the end of a def or at the end of a loop in a Python word. You also need to have a sense of when they will just nothing. Others say two things. I think those are kind of what I'm into so far. Dwayne, question. I think you missed the first part of my, and the hard things about teaching is when people come in at the beginning, or miss the beginning, they miss things they're supposed to hear. There is right here, leave a completely blank one. No white factor function definitions and standalone loops. So that was what we said. Now, I also from experience that there's a difference between hearing something and understanding what's being heard. I also think there's this phenomenon that people who document cognition have experiments documenting that I call the stupidity curve. Learning a subject, your knowledge increases. Then what happens is, whenever people are making progress, you actually see a dip in how people perform. So people get up to a point, and all of a sudden start to get stupid again. And then they start to get better. And the good period is very for long-term learning, because that's the period where people are getting the cognitive models of what they need to know. They're starting to internalize, and they're starting to get the concept. So it's not, this period is when you go from rote memorization to start integrate the various details in order to get something right.
And the period's going on 42 years. What's the normal stupid period? When do you start to come out of that? What's it?
I got 17 years of stupid experience on you. So. Unfortunately, I really can't help you. I don't know how to answer that.
I'm down here pulling Patty down with me.
Oh.
She's doing pretty good till she sat down. She's doing pretty good till she sat down next to me.
Okay, so, any other questions before I move to the next slide? One of the beauties of this language is that you can learn a lot. I learned a lot of Python by just sitting down typing things. And what happens is that you can tweak an example and for what a concept or mechanism will do by just watch what happens when you do a tweak. Another tweak. Okay? This division example, along with the division example, to me, was that the decimal points weren't lining up correctly. And what I have here is a tweak of the division example that's the numbers, turns them into strings, splits them on the decimal point, takes integer part, pushes right, and takes the fractional part and pushes that left. So you get decimal points lining up down the column. Making sense in terms of what this example is trying to do. Now, again, been following along in text editors, and I do encourage you in these slides to follow along in text editors. It could make it a little faster. For you who are single finger typers, we'll watch some time here to get this one right.
Split. No, just huge. I just told you, I said, go. The first year I wasn't. First year, after that. Good. Just keep talking. Word is not mine.
Quick, Bobby. Should I keep moving on this, or some confusion in the audience, but part of it is involving type failures. Well, circulate the slides and let people try some of these out on their own.
We'll just keep on going because people can kind of
Okay.
and all understand math, so we'll try to teach them now.
Let me.
The thing you're talking about.
Division is what happens when you take a pile of money that goes into the center and try to figure out who paid what.
Well, now I understand.
Division is a critically important part of real human affairs. Okay. Anyway,
I got through the class of fraction addition's tricky, friend.
what's going on?
There you go.
Okay, so what's going on? Here's the division part.
Additions.
You take a number, divide it by another number, round off to two places. 9 to 2, that would be 4.5, 4.50. 1 divide 3, 0.33, 0.3. Split in the point, that gives you a 0 and a 0.33, so, wait, 0 and a 33. Take the 0, flush it right here. Take flush it left, and we get, if you imagine this is a table of headings, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 over the headings. Over rows you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide by 1, 2 divide by 1, 3 divide by 1, 4 divide by 1, 5 divided by 1. This is 1 divided by 2, 2 divided by 2, 3 divided by 2, and so forth. Okay. So it's the sense of the apple. Okay. So, it's necessary for numbers. For those people who are not comfortable with numbers, one of the unfortunate truths about computation is computation is all about numbers. And the simple examples that you can give to showing how language works are driven by math. One really interesting feature of Python, to me, is one allows numbers to grow indefinitely. Number languages, if you try to multiply things that are too big, you get what's called overflow. Your program blows up because it says the same numbers are that big. What I do is try the examples just to get a feel for how big numbers can get. There are some links next to the different expressions that tell you how numbers can get. an example. To the 100,000th power. It gives to you like that. Okay. And what actually so far for coming. Okay. So 2 to the 10 to the 6, this tells you how many digits there are, and this is not a way of telling you how many digits there are. Let's see. Daniel, good. Joe. Great, good. Ben. Robert. Suitably big. Big. Okay. So this next example, given issues that I'm seeing with typing, instead of typing this stuff in, what I do is to type this in for you, and then what I'm doing while I'm doing the typing, and then I will turn back to the individual typing after the example. This is like the outer limits, where for the next 80 seconds you will not have control of the screen. Okay. Begin by doing, and you can run this on your own when the slides come out, is sorting, making available another called time. Time module that has support for performance evaluation. The two functions you saw before. The ceil and ten idiom is a way of trying to count the number of digits in a number without actually turning the number into a string. So I want to know how big a number is. And that's useful for getting stuff out. There are two ways to go. Take the number, you make it into text, and then you start counting the number of characters in the text. It is to figure out what power of 10, you raise 10 to take the log of 10 to get the number, and then use that to compute digits. So, that digits are there. I can either say length of the string, or okay. So it was the time clock to measure time it took to evolve to a nasty power. Then how much time it took to stringify that, then how much time it took to get the number of digits by using straight up math rather than by trying to go to text and back. So if you take 10 to the 5th power, you find out, if you 10 to the 5th power, you find that that's a number that has 30,000 digits. 2 times, really, 2 to the 100,000th power digits. If you compute, the compute time is really fast. To turn the number into a text is fairly low. If you and try to count digits, well, that's pretty darn fast too. Okay, let's go up to something like let's take 2 to the 10 millionth power. Okay, is capable of doing this sort of stuff. So I'm clicking on 2 to the 10 millionth power. Took me a couple of minutes to run. Risk of putting my audience to sleep. Let's back down and to 1 millionth power. Go a little faster. You go up. You start with bigger and bigger of 2. Let's say 2 to 2 million. While I was playing with the computation, was the null is one fast. Python you 2 to the 2 millionth power in less than 1/100th of a second. The time, how many digits there are in 2 to 2 millionth if you use logs is all fast. Where slowdown comes, you're going to take these big numbers and turning them into characters. Okay? So I have some on that. I'll come back to a conclusion slide, but the things I remember from doing my hardware course years ago as a grad student was that why would anybody ever do anything as silly as binary coded decimal? There's a format in mainframe, something called BCD. It allows you to represent numbers as a sequence of special coding where you don't use binary. I think that the string stuff, as long as it does in Python, is you can run the decoding in parallel. You have the representation, you don't have a clean separation between the digits. You have to take each digit and get it separately. What binary coded decimal, an old computer format, allows you to do is to represent a number that allows the digits to be manipulated separately. Okay. So just a kind of an angle on an aspect of computer hardware, but also an angle on what Python allows you to do. Python, if you need to work with really big numbers, integers will let you do that. Just be very careful about going back and forth between strings. So it takes me from the integer unit to the floating point unit. These are all fairly short examples. What I can do is go back to your keyboard, type some of these in, see what you get. Points. Exercises are breaking and doing strange things. Wanted to point to this example. With whole numbers in Python, if you drop a decimal number, a floating point number too big, you get overflow, and will break. It will say number too large, overflow error. There is also an inverse condition that mathematicians refer to as underflow. Underflow is that a number gets so tiny that it cannot be represented. A classic scientific computation package, whenever you get underflow, will tell you the number is small and throw its hand. And it's called an exception. Terms in a lot of newer languages, an exception is a widget that I can't go any further. I'm broken. Upon industrial overflow exceptions, you try to drive your floating point number too big. Python, however, is not for underflow exceptions. If your quantity vanishes to the point where Python can't detect it, Python will return 0. And that last loop returns smaller and smaller powers of 10. Okay. So when I had students kind of look at me, why do I need to know this? I think my wife, who went to graduate school, did a second degree in art. And the emphasis in art classes was what limits the media that you were working on imposed on you. If you do watercolors, for example, water is a very fluid medium, except it dries quickly. You have to keep your paper wet. or if you don't keep your paper wet, you have to be prepared to keep working. Oil is quite opposite in the end of the spectrum. If you take oil will stay moist for quite a while, but they don't have the same fluidity because of the thickness. And if you have some fluidity, you have to mix it down with turpentine or something to get a little bit different of a medium. Williams block is a different medium from woodcut. Woodcut is a lot grainier, but gives you different quality. The values you have in a programming language, data types that you have are not unlike artistic media. They certain ways. And if you're working in a scientific environment and using numbers to generate numbers, to me, it's important to know what limitations the numbers have. It's good, for example, in Python that you can push the integers as large as you want. But if you have a floating point, well, you go to blow up. And another odd feature, the math of infinity. You do have the ability in there to work with infinity, except it doesn't always do what you think it would. And in some languages, if you push a number too big, you take 10,000 to 10,000 power, the language will give you back infinity instead of going up. And that's kind of what I expected Python to do, but it does not. So in my teaching is never know until you try. When I go into classes, when I build these small examples, is that I never know what a language is going to do. Are there any concerns? So rather than have people try following, I will pass this form. And I will actually, since we're getting low on time, I'll run this example for people since it's a little longer. And, first time, if you have time, and you have a text editor, you're not going from a text editor into a session. Please, for the sake of figure out what's going on, get your text editor working somehow. Figure out how to go from a text editor into Python. And I'm about to do that with this example. Okay? This is an issue with floating point. It's not for just a Python, but I had an email conversation with Dave McWilliams about the point. He said, well, floating point, everybody knows the floating point has problems. And my comment was no. In a lot of computer science courses, is there's so much made of teaching loops and other related structures. You really don't see how the numbers work anymore. There's no time to teach how the numbers work. Numbers. And one of the questions back from when I was learning computing was you cannot cross numbers with decimal points. And I'll show you. Okay. This is a small shape where take some. I'm going to do basically 4 times 1/4. 5 times 1/5. Times 1/6. 7 times 1/7. Right? Or it should come out to 1. I'm going to take a 7 times 1/7. Take 1/7 plus 1/7 plus 1/7 plus 1/7 plus 1/7 7 times. And there we go. I'm going to ask part of a loop. So I found that 1/2 plus 1/2 is 1, and then 1 times 2 is 1. 9 plus 1/3 plus 1/3 is 1, and 3 times 0.3 is 1. So that's good. Next, I found out that 1/6 plus 1/6 six times was not quite 1, 0.9999. 6 times 6, I get 1. And down through 1/8, it's 18 is 1. 1/18 added to itself 18 times 1.000002. Okay. Now that seems it's not far off, but the point is, if you write a code and you're doing a test to see if a floating point number is exactly equal to what you think it should be, you're doing this wrong. Point numbers over time suffer from bit rot. Okay. Little discrepancies creep in, and you need to be aware of that with Okay, so Bobby, about 10 minutes to 5. I have stuff on complex values, some stuff on quasi-numeric stuff on, and some wrap-up notes on scalar values. Okay, so how would people suggest that I proceed? Have enough people in the submission?
You're going to slide that says complex values. That's a good place to stop. Until the next time.
Okay. Do you have any questions or concerns about what I've shown so far? Gavin. You exponent range, bigger exponents, and you can get more precision. I don't remember exactly how the IEEE 754 standard works, but I think you can get a few more digits of precision, and you can get. But Python, I don't think you have the ability to declare a float as either single precision or double precision. Standard languages, more mainstream languages like C++, like Java, you can specify how the numbers are going to be. Python, one of the simplifying features of Python is Python takes that away. What the environment gives you. And so it's good. In some ways, it's not. You have to find control over space. And sometimes space is important for making the computation run efficiently. Does that answer your point? Question. If there, then let's close down for the week. And Bobby and Chris, if I could talk with the two of you at least for a couple of minutes after the presence, after the people are gone, that would be good.
All right, everybody. See you next week. Have a good weekend. I don't know. We didn't talk about that. Okay, we didn't look at all, but that's fine. Just over.
Amen.
Look at it later. I think I got wrong.
I try and refuse to verify. Hey,
Thanks, Bobby.
sir.
Sure.
Yes. I can't believe you're here.
I'm not sure. Say, other than Joseph, I failed.
Why did you fail?
I tried to inherit some very simplified examples.
Mm-hmm.
And then,
I mean, I did a lot. Yeah, no, I think so. Type, completely type. They'll never get along. Yeah. And, you're gonna type. You're gonna make mistakes. You're gonna get syntax. I didn't code for
I did, I don't know it.
It's on also called Learn Python Hardware, and basically having in program super simple. It is Python too, but simple with just print statements. So the just says that you need to type everything in. You type everything in, and it will eventually proceed. You just
I thought I started off at a pretty low level here. But if you don't type it, I don't see it's any good for
Hey, Jerry, what do you think? What you think? Come on, let's have a.
But my concern, when I have people in the audience telling me that they know how to do division and they don't know how to get something to a multiplication table.
So, how do you think? Is this the right level of this class? Is it simpler or
There are systems, and so they're not mathematicians. That's what Ronnie put upstairs with John. Hung down why I don't know. That's sure about the
I was in elementary school. Yeah. Well, with the functions, if people can't follow elementary school math, we're doomed.
Yeah. We may be doomed.
We may be doomed.
Getting lost in functions, or they get lost in math, or is it?
Probably combination.
Is it
I mean, no, I mean, I guess. I can't type that. Let's get stuff in there. With my Python focus. 2 places. Wow. But I don't know what's wrong.
How do you think about the level of
that it was
good enough? Or
I think it was a little just for to get myself. I mean, the math isn't one problem. You know, it's not I'm not gonna whatever. You know, sorry, all of it, but I'm also I wrote it up for class Python, so I already understood.
You were good.
But it seemed like people were pretty confused
The syntax, yeah.
because it was pretty
Yeah.
So, down, bring it down more simple. Like, here's how you print hello.
Yeah.
Now here's how you do it, print dot format. Now here's how we can. I think you're heading there. I think estimate how basic you can start at. I think basic, as basic as you can be, go 2 steps more basic than that.
Yeah.
Orient.
You know,
There is a sense that it should be completed by some, by 320. I didn't get any further than answers and voting.
Yeah.
Voting.
And that's fine. If we don't get through it, we don't get through it. I'm not in a rush. I wonder if we're shaking people's.
One of my frustrations here is that this is a computational science, computational science, and people have, this is scientific computing.
These are learning scientific.
Learning.
Yeah.
But if you don't have done that, and you're trying scientific computing, and
Do the math.
one of our instructors was teaching the first learning class, being really afraid because he had students who couldn't take 10% of 10 hours. Went for calculating.
Oh, yeah.
Yeah.
Except
I don't think it's the math. I think it's the
People can't. People can't do what.
I think it's they don't have a programming background. So if you talk about in links and formats, they're not supposed to. Well, I think is what's happening.
some people are not.
I think there's a lot of people. Well, he is a bit.
yeah, those 2 guys.
So they had a program.
No, that's not.
Sysadmins don't like, they'll take codes and modify stuff. Get sysadmin programs to understand the problem of some level, of some kind. Yeah. So it's
So the consensus is that people should not be expected to understood in the state.
Not with the basic print.
maybe a basic print, but maybe spend more time on how the format works.
Print out the format. It can be awful. You can make it
Yeah.
really bad.
Appreciate it. I thought that I was showing this with the fairly basic.
We made a really good point. Floating point. That's the reason that most file programs are still within COBOL. That's the reason. COBOL program makes $100,000. As auditors, they come in Python or something like that, they're like, say, still good. If they're going to proof of books on it's all, it can't be all file too. So,
Is that?
that's 50. But now it's back. They've got object COBOL. They've got
COBOL is still the single world after assembler. I think most of the world so it's
being upgraded because they got upgraded powers for it because of money. It handles everything.
But before long, it'll be Parallel COBOL. High performance COBOL.
HPC.
HPC.
Yeah, they handle it hits, and that no matter what you get, just provide it easily. Get it done. So that program you remember, I guess when